All right, going to go over the review sheet for you, with you. And going to start at number 1, 1, 2, and 3. These are just, do you have these in your notes? Which transformation would be reflection across the x-axis? All right, and that would be where the y changes because you're going across the x-axis, and so that would be B. And then across the y-axis is where the x changes, and so that would be A. And across the line y equals x is where they flip-flop spots, and so that would be D. And then if you have those kind of notes to help you along the way here. So for number 4, you have to use a vector. Anytime you're using a vector, it's adding this first part to the x and the second part to the y. So -5 plus -2 makes -7. And then -10 plus 8 makes -2. For the next one, you do the same thing. 6 plus -4 makes 2. And -13 minus 9, or -13 plus -9 makes -22. The next problem, number 6, triangle EFG has coordinates E 2, 4, F -7, 0, and G -6, -3. What are the coordinates of the images of reflection across the x-axis? And so I need all 3. E image, E image, F image, G image. And across the x-axis, was x stay the same, y change. So 2, -4. -7, the opposite of 0 is still 0. And -6 and -3 becomes +3. Number 7. Number 7, if you were going to counter 180-degree rotation, you got to have the rule. What is the rule for 180-degree rotation? 180-degree rotation, xy becomes opposite x, opposite y. And so C right here is 7, -3. And so the opposite is -7, and the opposite of -3 is +3. (270-degree rotation, 270 degrees. So 270-degree rule, xy becomes y -x. And so 2, -3. -3 now goes first. And so it'd be -3 here. It's just not showing up well. -3 here, and then -2 second. This is a slide from right across, so that would be translation. This turns, and so that's rotation. And this flips, and so that's reflection. Number 10. And this is the one I said the letters got all screwed up on. So it'll be triangle JKM has coordinates J. Oh, actually, this one's right. On yours, it's all screwed up. This one's correct here, but I think yours says JKM here, JKM, and then it says JKL. And so that's, just flip the 3 points here, or 90-degree rotation. So this should be JK and M image for you. Now, 90-degree rotation. You know the rule for 90-degree. 90-degree XY becomes opposite YX. And so 6, -4. 6, -4 for the first one becomes +4, 6. K becomes +2, 3. L, or in your case M, becomes -5, 4. And again, the graph's there if you needed to help you, but you didn't have to use it. Y-axis. I got another rule for reflection across the y-axis changes the x. And so my answer here would become negative 12, 9. That's supposed to be negative 12, 9. My marker is not working real well right now. Y equals 5. Y equals 5 is a line like right here. Y equals 5. And so if I just talk about D, to get from here to here is 10 spaces. How is it 10 spaces? Well, this is negative 5 down, and I'm going to 5 up. So I go from negative 5 down to 5 up is a 10, just about the Y, 10 difference. And so if I was to go 10 higher, I go 10 higher, my new point was be way up here, right? The X didn't change. So for D, the X is still negative 8. 10 higher than 5 is going to make the Y 15. Okay. I do the same kind of thing for E and then F. E, this difference right here is 9 up, and then 5 more is 14. All right, it's 14 difference. And so negative 6 stays negative 6, but now it's going to be 19 high because I'm going 14 higher up here. Last but not least is F image. F is only 8 away. And so if I only go 8 away this way, it's going to be going from 5 to 13 high. And so it stayed negative 1, but now it's 13 high. True or false, a translation. Well, to me, it looks like a very, very prime example of a flip, which is a reflection, not a translation. And so that would be false. 14. What is the image of B after it moves along the vector 3, negative 8? And so negative 5 plus 3 and 11 plus negative 8. Negative 5 plus 3 is negative 2. 11 plus negative 8 is 3. Negative 2, 3 is the first one. Jack is planting trees along a path in the park. He wants to plant trees equidistant, which means they're equally as far from the path. If G and M are a pair, M should be planted where? Well, if G and M are a pair and G is 2 to the left of the path, then M, if I was going to put M, should be right about there, or right in this area, 2 to the right. And so what are the coordinates there? That's 1, 2, 3, 4, 5 to the right, 1, 2, 3, 4, 5 up. And so those are the coordinates, 5, 5. The vector that translates, and so I want to figure out the vector. I'm going from negative 2 to positive 6. So how do I get from negative 2 to positive 6? Negative 2 to 6. Negative 2 plus what makes 6? And the answer there is 8. And then I'm going from 7. From 7 to 4, I'm going down. So it's negative. I'm going down 3. So it's 8, negative 3 is the vector. It's like this one is 6, 9. Why? How did I get 6, 9? I went from 12 to, negative 6, 9. I went from 12 to 6, so I went down 6. I went from negative 5 to 4, so I went up 9. Reflection from number 3. The reflection in y equals x means things flip wholly. And so this would have started out as positive 32 and negative 41 to flip to negative 32, positive 41. Right? And then we have to go, all of these points going to go along this vector. So M image, -3 plus 5 is 2. 7 minus 10 is -3. So 2, -3 means it's not this one, and it's not this one. All right? And then I go n image. N image. 0 plus 5 is 5. 4 minus 10 is -6. Well, they both stayed that. And so now we go P image. P, 2 plus 5 is 7. 6 minus 10 is -4. And so this one ends up being correct. D. 20. Oh, man, there's a million different examples here. You just had to draw one of them. I'm going to draw my XY plane. And then if I just put a point here, and I'm going to call that point P, and I draw the same point on the other side, all right, of the y-axis. So it flipped across the y-axis, and now that point is P image. That would be good enough. 21. All right, draw a reflection. So I need to draw it as a reflection across the x and then y-axis. So x-axis, this is one high. I'm going to go to one low. This is one high. I'm going to go to one low. Right about there. All right. This right here is 6 high. So I'm going to go, and it's 6 to the right. So I'm going to go 6 to the right, 6 down low, right about there. And so that's my first image. Now I'm going to flip it over across the y-axis. And so this is 1 to the right. So now it's 1 to the left. This is 7 to the right. And so now it's going to go 7 to the left. This is 6 to the right. And so now it's going to go 6 to the left. And so this is my new true image after 2 flips. Flips there and then flips there. Right? Is this an example of isometry? Yes. Why? It stays the same size and shape. And that's the last problem. So make sure you do the online review if you haven't done it yet. And you can do your